Shpintova, and I'm a graduate student in aerospace engineering at the University of Illinois. Aerospace engineers use scientific principles to develop aircraft and spacecraft, like airplanes, satellites, rockets, anything like that. It's very important because that's what makes our travel and communications fast and cheap today, but I really fell in love with it because I think there's a kind of wonder in being able to take a giant heavy piece of metal machinery and lift it up into the air safely. Besides designing technologies, we also put a lot of time into studying how gases and liquids flow. One of the most important things that we study and measure is pressure, and that's because that's what makes a lot of our technologies work. For example, the higher pressure on the bottom of an airplane wing with lower pressure on top is actually what creates a force that lifts it up and allows the airplane to fly. When we test devices that we design, we have a lot of high-tech ways to measure pressure. We have sensors that use a spring to move an arrow on a dial. We have sensors that give us an electrical signal that we can automatically record on a computer very quickly. We even have paint that glows brighter under lower pressures, which has its own benefits. But all of these methods have a slight problem, and that is that they're not directly related to pressure. So they give us a signal, but it doesn't really mean anything. It's kind of like having a measuring cup, but instead of having cups along the side of it, you actually have inches. You know, your recipe calls for cups of flour in your cake. How many inches make a cup? You really don't know. So what we have to do is calibrate these devices, which means we measure a known value and then we set up a relationship. In the case of the measuring cup, we could take a proper measuring cup and see how many inches actually make a cup, and then we could use it just fine. In the case of pressure sensors, we need to measure a known pressure and relate the signal we're getting to that known value so that we can use that high-tech sensor. One of the types of sensors that we often use for calibration is called a fluid-filled manometer. It's comprised of a tube that is filled with fluid, and it can measure the pressure between two ends because the height difference between in the liquid columns actually changes, and you can measure that difference. That relates directly to the pressure, so you don't even need to calibrate it like the other tools. It just automatically gives you pressure. So even if a lab uses these high-tech, expensive, high-precision, very special sensors, you'll probably find a liquid-filled manometer sitting somewhere in a corner as the old reliable workhorse that we always go back to.